Okay. So I'll start. Okay. So my name is Gilad Shpitzer. Uh, Born and raised in Israel, but I'm quite often here in the United States. We also got operation in the United States. I'm in the field of air measurement for more than 25 years, from source testing, analytical laboratories, and to the high end, what we call remote sensing. This session is about ethylene oxide, and I heard a few of the presentation also from Emerson and the last one. And I think all of them was a little background for my presentation that will sum up maybe all of the ideas that you heard. Let's see. So if there's something that I want you to take from my presentation is that today there is enough experience in implementing Fenceline monitoring. My first project with Fenceline Monitoring was in the early 2000s, actually in 1998. This technology has been around. There's a US EPA method for open path technology like the TO16. And now there's a new rules in California that says that everybody should measure with open path, Fenceline monitoring, and new rules in Colorado coming up, and a few installations in Louisiana, Texas, Canada, Middle East. So this technology is well established. Our technology using a good FTIR with our algorithm and software can give you a detection limit of 1 ppb, and that is lower than the TCQ 2.4 ppb threshold. And what's unique about this, that it's based on official US EPA method. And if you don't like the US EPA method, there is also ASTM method that allows you to do the same, and the European method. And you can do it under accreditation. So we heard a lot of technologies. Some of them are good, some of them are better, but they are not official. This is an official, validated technology. But when we talk about Fenceline monitoring, and in California and in Colorado, you need to report to the public on real-time basis. Then you need to have a good software. They do a lot of quality assurance. Otherwise, you will report to the public bad data. And I think this is the most important thing. You cannot tell that a person will go to look on the data. There's millions of data points, and it must be automated. And that's what we accomplished at Atmosfir. And knowing that you've got high concentration of ethylene oxide or other chemical is a part of the problem. You want to know if it's coming to your facility, whereabout to fix it. So source location is another thing that you need to do. And the good thing about FTIR, or about our technology, that you can measure simultaneously, not just the ETO, but also the ethylene glycol, and all of the other compounds that are in the same facility. So a little background about Atmosfir, just one slide. So Atmosfir is a data software research and development integration company. We provide advanced air monitoring from environment to safety to security solution. We choose for our client the best hardware that we can find. And with our algorithm, we enhance it. So we are not connected to one manufacturer. We work with all of them. The company has extensive experience developing method technology for air pollution measurement. You heard some of the names before, like method OTM10 for doing the flux estimation. So our scientists worked that method. And we also actually, one of our scientists invented the open path monostatic system, Dr. Robert Kagan, and was the guy that wrote the method for the ASTM, etc. We did projects from Australia to the oil sands in Canada, Middle East, California, and Texas. So we've got 24/7 operational headquarters. And I think what is important more in Europe, but it will be also in the United States, it's that we carry out ISO 17025, meaning our result is accredited by accredited laboratories. And I remember the first time I came to the United States was in the year 2000, and it was a source testing conference, if you heard about the Source Evaluation Society. And there was a question, who of the company is accredited for ISO 17025? So we raised 3 people our hands. It was our from Israel, one from Mexico, and another one from Europe. And I think today all the source testing group are accredited for ISO 17025, and it looks like it will be the same with OpenPath and ambient air monitoring. So keep it in mind. So why ethylene oxide, the next Fenceline measurement? So we had the previous talk that it's very explosive, very carcinogenic, and it's all over the news. This is just from last week. California measured 24 sites, and you got the talk between the TCEQ and the EPA about what should be the threshold, and a lot of talk about it. So it's in the news, and if it's in the news, it will be the next thing to monitor. The previous talk about this debate, and then there was a big measurement campaign in the United States, and yes, they found out that the ambient concentration, or the average ambient concentration in cities in the United States, it's around 0.2 ppb. And as my previous talk was talking about, those concentration of the US EPA are not realistic to measure. Not using a Suma canister, not using a solvent tube, and for sure not using any analyzers. While we go to the TCEQ recommendation that it's for 1,000, 2.4, now it's 10 times more than background, so it's logical. There is instrumentation that you can measure it. So it's really problematic, like my previous talk about. How can you give a threshold that no one can measure? And if no one can measure, how can you control it? So if I was the guy that make the decision, I would go with TCEQ, going with something that you can measure, something that is 10 times more the threshold, and not go to a number that no one can measure and follow. So what is the challenges of the industry? Fugitive emission are the major contributors to the amount of air pollution emitted from chemical industry, and it includes also the ethylene oxide. And real-time Fenceline monitoring is the appropriate way to monitor those and reduce the risk and the environmental impact of the industry. I heard an EPA presentation a few months ago, and then the EPA official says that more than 70% of the ETO emission comes from upset from equipment and human errors. And the only way to measure human errors, so to catch them, is to measure 24/7 real time. 2 years ago, I think there was an explosion in Spain. 2 people were killed. And I'm not sure about that case, but if it was caused for a leak, if you can measure it on real-time basis, and then maybe you can stop the explosion and save a life and a lot of money and bed for the name. So because human errors can happen at any time and anywhere, you must measure along lines, real-time monitoring 24/7. Passive sorbent tubes will not give you the answer because they average for 2 weeks, and then you send it to analysis. What good is the data if you get it 1 month later and it's average for 2 weeks? You cannot do nothing with this data. And the same goes with the canister. So it's, you don't measure for 2 weeks, but you measure for 1 hour, and then you send it to the lab, get the results maybe 10 days later. And then again, how you do the correlation. So real time is a must, for my opinion. And the idea is to finding and solving the problem earlier. And if you correlate it to LDAR project, so every day that we expedite the repair, we save 1% of the emission. They take 100 days between each cycle of the LDAR. So if we find it the first day, we save 99% of our emission just by time. No added money into it. And that leads Atmosfir to the idea that we want to develop a system that will tell our clients when something can happen, and that's meaning measurement real time 24/7 with line captures. We want to tell our clients what is happening. We don't want to tell them they're just VOC. We want to tell him if it's ethylene oxide, ethylene glycol, so they can do 1+1 and know where it's coming from. And if they don't know from the composition of the compound where it's coming from, we've got also a fusion of meteorological data together with the concentration data, and that will lead them to the source location. And as one of the others spoke about, concentration is just one part of the picture. We want to tell our client how big is the leak. So if we got no wind, we can have high concentration because we don't have turbulence. And if we got a very high wind, we can have very low concentration due to high turbulence, and nothing is related to the concentration. So we will give our client the ability to see in the same time concentration and what we call beam flux, meaning we take the concentration and multiply by the vector of the wind. A little bit about the open path technology. So what we can see here, it's an open path FTIR. We use the Brooker FTIR just because it's the most fast scanning and the most high resolution and the lowest noise signal to noise ratio, and that gives us the ability to give the best detection limit, and it's also robust. So this is a $6.5 billion company, while the rest of the manufacturers are usually small. And that leads to engineering problems like it hit, you need to open it, that will work like a Mercedes here and here without problem. We shine a bit of infrared light into a retroreflector on the other side, and that configuration calls the monostatic configuration. And as you can see, it's a Canadian patent and design for one of our PhD, Dr. Robert Kagan. And the energy bends back, and then we do the spectral analysis based on two laws of physics. One is the Bell-Lambert law that says the absorbed equal constant multiplied by concentration in the path length. We know what is the path length, and now we can tell what is the concentration. Just as a rule of thumb, each system can cover up to 1 mile or 1 kilometer of a fence line, meaning 500 meters that direction, 500 meters this direction. So average site, if you want to close it from all the surrounding two systems, should be enough. If you go to a huge site like you got in Louisiana or something like that where they manufacture, so then you will need something like 4 to 8 systems depending. So the advantages of the FTIR system, it's a multispectral, so we can do simultaneously a lot of compound. We can give you the ethylene oxide concentration, and we can give you also all the other compounds that are in your manufacturing process, like the ethylene oxide, the ethylene, the ethanol, the isopropanol, etc. So it's not like the VOC is something. We will give you the composition, and if you know your facility, just the composition will tell you where the leak is coming from. The second advantage is we are measuring along lines, so meaning we got a big coverage. Along line you can have multiple or endless points, so that is the difference between point monitor and open path monitor. And the first thing that I want to say, it's based on validated methods. So we got the EPA, the EN, the ASTM. As I told you, we've got ISO 17025 accreditation, meaning our technology and our software and our result was validated, and they should be acceptable all over the world. But spectral analysis, it's not an analyzer. If you don't know how to do it correctly, if you don't take into account all the interferences, if you don't write the good spectral method, and if you don't know to take the right correlation coefficients, and a lot of the manufacturers use R square. R square is statistical correlation, and it's nothing to compare shapes. Then you will have a lot of false positive and a lot of false negative usually, meaning that you will not report what you need. And that's bring us to the, I think, the most important thing when you use multispectral analysis is good quality assurance in real time. And this is a screenshot of our system. So every number that we will report, it's that easy, and you can come to our booth. You just click on the number and it opens the spectral validation. Spectral validation, what you see in red is list of PNNL reference spectra with high resolution. Blue is what we are measuring on the field, and that is absolutely certainty. Actually, what I said now, it's a calibration. So each measurement that we do, we actually do it against reference. So if you do it in the highest resolution, with the same resolution and that you got at NIST, so every measurement, it's a calibration, and that means that you don't need to calibrate it often, or you don't need to calibrate it at all. Every measurement is a calibration. So we talked about where the emission coming from. So because we're measuring source, we got FTIR at the chimneys, the source, we got the GCs in the source, and we can control the source quite often. If there is a leak going out of a duct, we will sense it. But we will not sense if someone didn't connect a connector properly, didn't close the valve properly, or you've got a fugitive emission. So if this is our chemical complex, where should we put our point monitors? So the answer will be we should put it all around, and how many. So if we go with the method 325 methodology, so we will need to do something around 20 samples points. And if there is facility closer to where we are measuring, then we will need to add more and more points. And because air pollution moves with the wind, if we will put our monitor here, we will not sense nothing, but also here. If we will put it on point T, we will overestimate our concentration. So it's not bad for the industry all the time to use an open path instrument. Yes, we will collect everything, but we will represent the data more correctly. So if we will take the concentration from point E, it really doesn't represent the emission from the chemical complex. The true representation will be along lines. And if we will measure along lines, then we can correlate to the flux correctly, and we can give the good pictures. In other words, open pass fence line measurement represent emission when measurement are near the source. If we are in the chimney, you can use a point monitor. If you are far away from the facility, use a point monitor. But when you are on the fence, either use a lot of point monitors, and a lot meaning like every 50 or 100 meters put a point monitor, or use an open pass technology. As I said before, those are the EPA method, along with the OTM10 that allows you to give the source and the emission. And what's good about EPA methods or ASTM method, someone had validated them, and you got quality assurance procedure, and you can compare detection limit. Today, every manufacturer claims that he can do that and that detection limit, but it's all correlated to time. It's all correlated to a lot of other things. And if you don't have one procedure, then you cannot compare the different detection limit. I will do the source location again. Air pollution moves with the wind. We find high concentration on one segment of the fence line, back triangulate the wind. The wind change a little bit. We do again back triangulation, and we can tell you the source. So we will tell you if it's coming from your facility easily or from your neighbor, but where about, then we will need a lot of statistical data. And imagine we've got something like 5 minutes, we got a cut point like that. Then we use a lot of statistical algorithm how to separate, let's say now we got 2 leaks. So if I don't know to count for 2 leaks, I will give you the source in between them. So there's a lot of know how to do it. But then in the end, in the control room, there's sitting an operation guy, and he doesn't know to do the math. He wants to see a map, and he wants to see color. And the brighter the colors, meaning the higher possibility that the leak is coming from there. And now people can go and try to see if there is a leak over there. So we want to do it. My goal was to create a system that everyone with one finger and no brain can operate it. And I think we accomplished it. So source location will be a very important issue, especially in a very dense chemical complex. So what we accomplished in Atmosfir, we take the best hardware. So if you need very low detection limit, I would recommend go with the Brooker FTIR. If you don't need very low detection limit, you can go with different manufacturer. Not give the other names, but there are plenty. We take the best hardware, we put it with our patent algorithm, and with that we can give you automatic source location, the best detection limit, and it's very important for ethylene oxide, in California for acroline, and we can give you a lot of quality assurance. So I did it long ago, and we will discuss a little bit of each one of the technologies, the pros and the advantages, etc. So we'll start with this Emerson point monitor electrochemical. So it's cheap, it's explosives proof. As he said, we can put it by 1 hour. We will have all the data on our website, but it's not good for PPP levels, first of all. And secondly, you need to calibrate it quite often. You need to maintain it quite often. And sometimes, like the PID, or a lot of them are not very specific for one compound, and you will have a lot of cross interference. But it chips, and you can put it in a lot of places, and there is a use for it. We go to the second option that we talked about. It's the canisters or the sorbent tubes. So canister, it's a point monitor. We open, suck the gas in. We can go very low detection limit. We can go 0.5 ppb or 0.05 ppb for ethylene oxide. But then you don't have real-time result. You will have the result sometimes 2 weeks afterwards. And if you talk about the passive sorbent tube, then the detection limit in the ppb level will take you something like 2 weeks averaging. And if you compare 1 hour, they will be in the ppm level. So they are not that sensitive, and it's all related to the time that you are measuring. But they are also very cheap to use. They don't need electricity, but they will not tell you when the problem occurs, and then you cannot fix it. Then we go to high-end point analyzers, and there will be the Picaros and the PTRMS. And either you can drive around or you can do a multiple tubing. Those are quite problematic when we're talking about ethylene oxide. First of all, it's very soluble in water, so you need to do a lot of fitted line. So now take a 1 kilometer of fitted line. We're talking about electricity, we're talking about explosion, and we're talking about if you got cold spot, then the ethylene oxide will absorb in its cold spot. So I will recommend those if you want to do one source, but don't go all around the facility with tubing. A lot of problems can go with these things. And then we go to the open path instrument. In the case that we are talking, the most suitable will be an FTIR. We can go to PPP level. It's a proven US EPA method. We will not go below 1 ppb. But if the threshold will be around 2.4, we are well below that. We can measure it, and we can give real-time data with certainty. So what we can see, it's all the chemicals that usually in manufacturing site, and you can see the mass, and the idea is how to separate it. But after we separate it, then you can see the picture of that. Here it's a Texas campaign that we did, and we are talking about concentration of ethylene oxide, 5 ppb, with detection limit of 1 ppb, and the path length was 250 meters. Red is reference from NIST. Blue is what we're measuring in the field after I take all the interferences out. And now no one can claim that there is no ethylene oxide. You can see it with your own eyes. And the higher the concentration goes, it will look better and better. And when we are in, this is 20 ppb, it's almost look like identical completely. So, and this is again, field measurement from Texas. So with the humidity, with the dust, with everything, and we can do it. One of our clients in the Middle East want to do what we call the holistic solution. So the holistic solution says in the pipe, we got concentration of percentage or ppm. Usually it will be something like 30% or 100% of ethylene oxide. So when it goes, we're talking near the source, we're talking about percentage or ppm. But by the time it comes to the fence line, we're talking about ppb or sub-ppb levels. And that leads to different technologies. So for the inside, we can use point monitors that are not specific, like those cheap point monitors that we saw from Amazon, explosive proof, easy to put. But for the first line, we will need very sensitive and very specific. So the idea is we got to learn something here. We don't know if it's ethylene oxide or something else. We wait until, and usually the average when it's 2 meters per second, so it will take less than a minute to come to the fence line. We will find the concentration, and then we will do the specification. If it's ethylene oxide, ethylene glycol, and we can tell the source. So now we got two ways of telling what is the source and that we got a leak. So it's a combination of two approach. So we are talking about open path on the fence line and point monitor inside the facility, all compiled into one software that will give you the greater picture, when something happened, where it happened, what happened, and how much is the flux, all based on software. So, in other words, fence line measurement can be the nose if something goes wrong, and this is all the idea. We, as a facilities, really doesn't care if it's 0.1 ppb or 0.15 ppb. We want to know if we got a problem. We want to fix it before there will be an explosion or before we go over the threshold that hopefully will be something like Texas and less than what the EPA claims that no one can measure. Because the fugitive emissions are usually from offset, we must have a monitoring that measure 24/7 real time. We proved under accreditation that we can measure ethylene oxide with 1 ppb detection limit. And with the same instrument, we can measure a lot of other compounds that can be emitted from that facility. It will improve the safety and the environmental challenges. And that's about that, I think. So if you've got questions, we are free. We are located also in California. Hopefully we'll open a new office in Texas in the next year or so, and in Israel. So if there's any question, I'm happy to answer.